Good morning, pre-algebra. So here is our joke of the day. Why did the rapper carry an umbrella? Faux drizzle. That's right, faux drizzle. All right, open up your books to 374. I will let you take a moment because you're probably laughing so hard. 374. All right, we're continuing with our using percentages and proportions, all that kind of thing. But really, for this today, we're really going to be working with this magical formula. I equals PRT. I means interest. Interest means the money that you get that builds up over time. So how many of you, when you grow up, you want to make money? Yeah, I see you raising your hands and virtually. You want to make money. And one of the easiest ways to make money is to invest it. And investing means you put it in a bank account or you put it somewhere and money will grow over time. And that's the idea of interest. That's how it grows. So when your parents put money into a savings account, or maybe they've created a savings account for you, over time you will earn interest, which means that over the period of a year you could earn some money and you didn't really do anything. So an example, when I was a kid, we had a savings account for me, and whenever I get birthday money or whatever, sometimes we put it in the savings account. And over a year, my bank account would be like a couple cents more just because of that interest. The bank pays, a part of that money, and it's called interest. And so we're going to be finding interest. And so the way that we do that is we have three main parts. The first one is our P, principal, not Miss Sanger, but it's the money that you started out with. So started out means invested. That's like the money that you put in the bank. Or, if we're talking about a different situation, it could be the money that you borrowed. Say you got to pay someone back. So for me, I had to take out loans to go to college. So now I have to pay that money back with interest. And so I borrowed that money. Alright, so that's the first aspect, is figuring out what your money is. That's what you want to look for. The second thing, the R. The R is the interest rate. This is a percent. Alright, so it'll say at 5%, or typically it's got a decimal, 4.2%. So that depends, that you would get, that's the amount that you're talking about, a percentage of this amount of what you started out with. And the last thing, time, which typically is in years. So they'd say 4.2% a year. So thinking about my situation with a savings account, I would earn money every year. It would be like 1% or 2% a year. So 2% of $200 would be $2. So I'd get $2 added into my account every year. Because I started out with 200, I multiply that by 2%, and it's 1 year. So that would give me my interest of $2. So I'll write that out. We have I started out with 200 bucks, and I'm just putting it in parentheses to do the multiplication. We had 2%, so that is 0.02, and I'm just talking about 1 year. So typically you always want to do T as in years. So that's something to watch out for. So if we do this math, we would end up with I equals 2. Unique $2. Okay? Pretty simple. You're just plugging in numbers and you go from there. So let's start with our first example problem. I'm going to write up our magical formula up here. Alright, example number 1. It says $1,000 at 4.5% for 2 years. So what is the interest that you would gain to the nearest cent? So that means we're going to the hundredths place. So we started out, our initial amount, our principal, is $1,000. So I'm going to say I equals 1,000. Next thing is our rate. What's our percentage? 4.5. So I need to do 0.045. And how many years? We're talking about 2 years. Okay? When we multiply all that out, our interest will get to I equals 90. So what is that? 90 piñatas, 90 chihuahuas? No, that would be $90. That's right. $90 is what your interest would be. That's how much you would earn over 2 years if you put in $1,000 into the bank with a 4.5% interest rate. All right, let's do another example. I'm going to do example 1A at the bottom of 374. So what about $2,250 with a rate of 6%? Ooh, that's really high. So that's 0.06 over 4 years. All right, we calculate all the math, and we would get 540 cute little puppies. No, money, dollars, dollar signs. All right, so this is the way you approach your problem when you're talking about interest. How much money you're going to make. How much money you're going to make. Now we're going to look at some problems that are going to say how much extra you're going to have to pay. So, story problem first. I need to take that back. Story problem. So story problem, top of 375. Mr. Gable borrowed, here we go, $18.60 to buy a computer. He will pay $71.30 per month for 30 months. Find the simple interest rate for his loan. Ooh, all right. So first thing, we always got to use our magic formula. This is always going to help us out, so you're going to want to memorize that. I equals PRT. So now we plug in the numbers that we know. So it says solve, first find the amount of interest he will pay. So we have to find out how much he's going to pay over that time period. So we're going to do 7130 times 30. Because that is his total amount. So that equals, gotta look at my book, 2139. Okay? So that number is the total amount that he's got to pay back. So even though he borrowed a lesser amount, he's got to pay more over time. That's the idea. So, for example, sometimes if you buy a really nice TV or a car, or maybe even a really nice Honda, you would pay over time. Rather than paying total up front, you would pay more over time. So that's what he's getting at. So now we've got to figure out, what is the difference? What is the difference? How much interest did he have to pay? So we take our final amount and subtract our original amount. So we've got 2139, take away 1860. Alright, and here's the reason why we're doing that. Remember, this is the amount that he ended up having to pay with his interest. So we are actually trying to find R. We're trying to find R. Okay, so we're doing the final amount, take away the original amount. And so he overall had to pay $279 more dollars. That's how much more he had to pay because he chose to pay over time, over 30 months, compared to all up front, $18.60. Alright, so now we can fill in our problem. This equals I. This is our interest. That's how much he had to pay extra. So we're going to do some algebra to solve the rest. So we have 279 equals, what's our P? Well, remember, 1860. That's what he started out with. Alright, we're trying to find R. And now we got to figure out our T. We're talking about 30 months. So we have to calculate that into years. So there's 12 months in a year, so we got 1 year, 2 years is 24, and then 6 months would get us to 30. So that would be 2.5 years. So remember, always turn it into years. Alright, so now we just do some simple algebra. We get 279 equals 4650R. Divide both by 4650. And we get a very small number. We get 0.06 equals R. So what is that? Remember, what is R? R is a percent. So is that 0.06%? Nope. Remember, we got to move our decimal place 2 points to the right. So we are at 6%. That was the interest rate. Okay? So this is a little bit more challenging, a little bit more difficult, but remember, you're plugging in the numbers that you know. So our first step was finding out how much did he actually have to pay. So you're going to want to look back at this problem. The next step was figuring out what was his interest. How much more did he have to pay? So we had to pay $279 more. Then, when we knew that, we had enough information to fill out our fancy program, our fancy, equation, and then we kept going. Alright, last one. Example number 3, find the total amount. So it says, what is the total amount of money in an account where $600 is invested at an interest rate of 8.75 compounded annually for 2 years? Alright, so we're talking about something a little different. We're still using our same formula, I equals PRT, but if you notice, there's a fancy word called compounded. Alright, so let's start with what we know. We are trying to find I, trying to find the interest. So we still have I. What's our amount that we started out with? It was 600, correct? Yep, $600. What's our interest rate? Our interest rate is 8.75, so that is 0.0875. And lastly, our time. This is where the compounded comes in. Our compounded simply means is that it keeps growing. So we're talking about 2 years. Alright, sorry, I had to take a little break there. We are going to solve. So instead of putting 2 years, we just put 1 year, because when we talk about compounded, it grows, continues to grow over time. It just gets tacked on. It doesn't matter the amount of years. Let me just double check that. Okay, I'm back. I checked my facts, so here we go. So compounded means that it grows over time. So we're breaking down, think of this one as year 1. So we're talking about 2 years, but we look at it over time. So we have to solve this, and eventually we would get, in the first year, he would have I would be $52.50. The thing about compounded is that it grows over time. So when we go into the second year, we actually add our $52.50. So now we're looking at year 2, so I'm going to kind of do a little ... So we're looking at I equals, we have to change this, $652.50. We still have the same rate, 0.0875, and we're still talking about 1 year, but this is the second year. So the idea, remember, is that compounded means that it used the interest that it gained early on. Alright, so go ahead and solve that, and I'm about to run out of time, so I will see you in real life.